Okay, welcome to 2.8. Every car on the road needs identification, and so does every device on the network. An IP address is like a license plate. It identifies each car uniquely on the road. A MAC address is like a VIN number, permanent and tied to the hardware. It never changes. Ports are like specific parking spots or garage doors. They make sure data, like cars, arrive at the right destination. For example, port 80 is the garage for web traffic. Networking isn't just about roads, it's about services. HTTPS is like driving a car with tinted windows and secure locks. It keeps your ride private and safe from prying eyes. FTP, or File Transfer Protocol, is like a cargo truck hauling goods from one location to another. And email protocols like SMTP or IMAP are like mail trucks carrying letters across established delivery routes. To get on the internet, we need devices that can connect us to bigger highways. A modem is like an on-ramp or off-ramp, converting local streets into connections with a global highway system. A router is like a traffic cop or GPS navigator, directing each car to the right road and making sure traffic flows to the correct destination. Other networking devices also play vital roles. A switch is like a highway interchange. It organizes and directs traffic so multiple cars can move smoothly without crashing. An access point is like a gas station or rest stop. It's where new cars or devices can join the road via Wi-Fi. And a firewall is a security gate or toll booth. It blocks unauthorized traffic. It only lets approved cars through. When it comes to how devices share resources, there are two common models. Client server is like a taxi service. The server is a central company providing rides, while the clients are passengers making requests. Peer-to-peer is like carpooling with friends. Everyone shares resources equally, with no central dispatcher in charge. Networks also come in different sizes. A LAN, or a local area network, is like neighborhood streets. It covers a small area like a home, school, or office. A WAN, or a wide area network, is like an international highway system, connecting cities, countries, and even continents. The internet itself is the biggest WAN of them all. In fast and furious terms, an IP address is like the license plate that identifies each car in a race lineup. The MAC address is the VIN, permanent and unchangeable. The ports are the garage slots, like multiple entrances in the Vault in Fast 5. HTTPS is Dom hiding his moves behind tinted windows. FTP is a cargo truck in the first movie's heist. And email is the mail truck, like when Shaw and Cypher intercept messages. The modem is the on-ramp, letting cars merge onto the freeway. The router is Tej acting like a GPS cop, directing traffic during missions. The switch is an interchange, like when the crew swaps cars mid-chase in Furious 7. The access point is a gas station, where cars stop and rejoin the network. And the firewall is a toll booth, blocking anyone who doesn't belong. Client server is Dom leading the crew as a dispatcher, while peer-to-peer is a team carpooling and sharing equally. Local area networks are the local neighborhood races in Los Angeles. Wide area networks are the global highways the crew travels in Rio, London, and Dubai. Networking, like the Fast and Furious family, connects everyone across every distance, making the mission possible. Okay, so just to recap, IP addresses are license plates, MAC addresses are VINs, and ports are garage slots. HTTPS is a locked tinted car. FTP is a cargo truck. Email is a mail van. Modems are freeway ramps, routers are GPS cops, switches are interchanges, access points are gas stations, and firewalls are toll booths. Client server is a taxi service, peer-to-peer is carpooling. Local area networks are neighborhood streets, and wide area networks are international highways. Networking is a racing map of IT. Addresses identify each car, services move cargo and mail, and devices like routers and firewalls guide the flow. Models like client-server or peer-to-peer show how cars can share the road, while local area networks and wide area networks define the size of the race. Just like the Fast and Furious crew depends on their maps, cars, and connections, IT networks connect every